2.3. 2.3. So we're still talking about equations. We did graphs last time, right? 2, 1, 2, 2 with graph. So here we are in 2.3, talking about some equations. Translate the following verbal statement into an algebraic equation. So the quotient of 2 more than a number and 5 is 8. So this is about word problems. Are these your favorite part of algebra?
No.
No? Second favorite, maybe? High on the list somewhere?
It can be because they're reading.
All right, so why don't you give that a try? It says use x for your variable. Let me let you try it before I do it. You'll get more out of it. Even if it's completely wrong, I think you'll get more out of it. Division, yeah. Quotient means divide. So it's like a fraction. So the quotient, the dividing of 2 more than a number. 2 more than a number. How do we write that?
2 on top.
2 plus x, huh? More means add, doesn't it? And the number is the x, right? Because we don't know what the number is, so that's our variable. The quotient, the dividing of 2 more than a number and 5. So there's the quotient of 2 more than a number and 5. The dividing of 2 plus x and 5 is, what's is in a word problem? There's our equals, huh? Is 8. There's our equation. So that's what they want you to type in on this line. And then on the next line, they want you to solve the thing. So how do we solve that thing?
Plug it in and bring the 8 over.
Remember when we have a fraction on one side and a whole number on the other, how we solve those?
Turn it into a fraction.
Yeah, put this over 1 and diagonal. Remember cross multiply? When you just have one fraction on each side, you just go diagonal. So we have 1, 2 plus x equals 5 times 8. Like that, that good? And then we distribute that 1. 2 plus x is 40. Last step to get x alone. Subtract 2. So x is 38. Those steps make sense? Number 2. 2 cyclists, 48 miles apart, start riding toward each other at the same time. One cycles 2 times as fast as the other. If they meet 2 hours later, what is the speed in miles per hour of the faster cyclist? Have you done these kind before? Are these your favorite kind of word problems?
No.
I know you have a list of favorite word problems, right? And this might be high up there.
Somewhere.
Yeah, these are some of the hardest ones. The travel. These are travel word problems.
These are physics, I think.
Yeah, these are physics. These are totally physics. Yeah. Being physics, what's the equation we use?
X, isn't it y1 minus y2 over x?
That's for slope. We're not doing
We're
slope.
doing slow.
Isn't it the distance formula?
Yes.
Yes.
And what is it? Well, there's a couple distance formulas. It is distance. It's one of the, not one we've had so far. It's not that old distance one.
Well,
It's not that one. Anybody know? In physics, how do you connect travel, speed, and
Is
time, and distance, and all that?
travel speed.
All right, let me jump in and help.
There's no videos on this. What's going on, man?
Do you guys use those videos that are next to the questions?
Yeah.
They looked good to me when I watched one of them.
Yeah.
I thought they did a pretty good job on those
But
things.
it stumped all the people at Ace.
It did? Oh. All right, so 2 cyclists, 40 miles per hour, right towards you. Okay, I'm gonna bring it over here and write down the details. So 2 cyclists, 48 miles apart, ride toward each other. What else did they say? Ride toward each other. One is 2 times as fast as the other. If they meet in 2 hours, what is the speed of the faster cyclist?
So we know we have 2 equations on this.
I don't think so. One is 2 times as fast. as the other.
Say 2 fraction.
If they meet in 2 hours, what's the speed of the faster? Did I get all that right? Let me double check. If they meet in 2 hours, 2 times as fast, 2 hours later, what's the speed of the faster? Write an equation, and then what's the speed of the faster? They want me to use R to represent, they said use R to represent the speed of the slower cyclist. Okay, I'll do that. I'll do what they say. All right, and we got the equation from physics?
I know it would have 2R.
Distance equals rate times time. Distance equals rate times time. If you're taking some physics, it's great stuff. It's very, very challenging. It's the hardest thing I did in junior college was physics. Physics. It's like math with all word problems. And it's very challenging. I have great respect for physics people. Distance equals rate times time. So, all right. So what we're going to do is, and then we're going to make 6 boxes, 2 underneath each letter.
He told you.
2 under the D, 2 under the R, 2 under the T.
That's what I told you earlier. You said do.
Distance is rate times time. And what we're going to do on this is plug in as much information as we possibly can. So the 2 cyclists start out 48 miles apart. Now that 48 miles, is that a distance or a rate or a time? Miles is distance, yeah. Now, the way it's going to work is we're going to put the first cyclist, or how about, they're calling them the slower and the faster, huh? Why don't we call it the slower and the faster? And then we're going to put this information. I had a student, it was like my 3rd year of teaching, so like 25 years ago. And he one time was trying to remember. He said, "You mean the dirt equation, Mr. Herring?" I thought, that's good. So for 25 years, I've been saying that to students to help them remember. It's like the word dirt, except the equals is the I, right? So it's the dirt equation. Distance equals rate times time. Okay, so now let's make sure you know how this table, this is what we always use when they have things in motion. So if I put like a 10 there's no reason I would, but I just want to get you familiar with what the table means for stuff. If you put a 10 right here, this means that the slower cyclist went a distance of 10 miles. Right? That's what that 10 would mean. What if I put a 3 here? What would that mean?
He went a distance of 3 miles.
That would mean the faster cyclist went a distance of 3 miles. Right? What if I put a 6 here? What would that mean?
That would be rate.
That's rate. Commonly called speed.
Speed.
Right? The slower cyclist went at 6 miles an hour. The speed, the rate. Right? And what if we put a 4 down there? What would that mean?
That would be your 4 hours or your
The time for the faster cyclist. That would mean the faster cyclist traveled on his bike for 4 hours. Good with the game plan? All right. So now they already told me what to do. They said, let R equal the rate of the slower. So I'll go slower rate, R, right there. They told me to do that. So I'll do it. There's the R. And if that's, they said that in the words. They said, let R be the rate of the slower. So if that's R, what's the rate of the faster? What's it got to be?
2.
Elizabeth, it's got to be
It's 2 times faster.
2 times faster. So if he's R, then the other guy is
R2.
2R, right? Twice as fast, huh? 2R. 2R. Okay. Now, what are we going to do? Well, back to that 48. That 48, is that a distance, rate, or time? It's a distance. Now, what should I do with it? Should I put it there?
No, because it says as fast.
Yeah, that wouldn't be right, would it? Because if you put 48 there, you'd be saying the slower guy or gal went a distance of 48 miles. Is that what they're saying?
No.
No, they're saying the 2 cyclists started out 48 miles apart and went towards each other.
Right.
Neither person covered the whole 48 alone,
No.
did they? Right? So like This, maybe the slower starts out on this side, and I'll put it over here. The slower starts out on this side, maybe, and the faster over here, and they travel towards each other, and they meet, and the whole distance apart that they started was 48. That's what they're talking about. Neither person covered the whole 48. In fact, where should the 48 go? It should go down there, meaning they should add up to be 48. Right? That's going to be the total of their two distances, isn't it? That's not going to be either one's distance alone. You see that? However far the slower goes plus the faster, together they're going to cover the 48 that was between them, aren't they? So I'll just stick it down here, knowing that means they're going to add up. These two distance numbers are eventually going to add up to 48, aren't they? All right, back to the problem. So I can't use the 48 yet. I already got the 2 times as fast with the 2r. So there's only one other number in there.
2 hours.
2 hours. Right, see how I'm just going through the numbers, making sure I put them in the right spots? Right, I got the 2 times as fast. That's the 2r. Okay, 2 hours.
Time is 2 hours.
They meet in 2 hours. Yeah, does that mean the time is 2? Like that?
Yes.
For both? Do I do it for both?
Yes, for both.
Or is it the total? Or is it just one of them? Or what's the story?
Isn't it the total?
Well, let me ask you this. They start out here. What do they say? Let's just be as real as we can with this. They start out here. They ride their little bikes for 2 hours, and they meet.
Yeah,
Right?
they meet in 2 hours.
So did the slower person? How long did the slower person ride?
2 hours.
2 hours. How long did the fast person ride?
2 hours.
So they're both 2, aren't they?
Yeah.
Right? Makes sense? They're both 2. All right. Now, as soon as you get 4 boxes, whoops, I shouldn't be erasing stuff. As soon as you get 4 boxes, notice we've got 4 boxes. So, in fact, let me write some steps. Here's kind of like the steps you want to take. Step 1, get 4 boxes from the words, which we do. We now have 4 boxes, don't we?
Where's the fourth one?
1, 2, 3, 4. We have 4 out of the 6 boxes.
Oh, okay, I got it.
Step 2, get the other 2 boxes. Whoops, I'm scribbling off the edge here. From the equation.
So we'll do 4 hours.
From the equation. Now, what do I mean from the equation? Well, what does the equation say? Distance equals rate times time. Remember, they're not just 3 decoration letters. They're in a relationship. They're connected, right? D is equal to R times T. So whatever goes in the D box comes from the R box times the T box. So what's going to go? So R box times T box is going to be 2R, isn't it? And R box times T box, 2R times 2? 4R. So you get the other 2 boxes from the equation. Does that make sense? You get 4 from the words and the other 2 from the equation. And now,
Repeat that real quick.
So-
Say it faster.
I got 4 boxes from the words,
Yeah, I got that.
and then the other 2 from the equation.
Oh, okay.
D equals R times T.
Gotcha, thank you.
And then step 3, use the front 2 boxes and write an equation. I can just kind of squish that in there. So use the front 2 boxes and write an equation. Remember what we already agreed on? That whatever distance the slower cyclist covered, plus whatever distance the faster, has to add up to be the whole 48, right? The slower and the faster together cover the whole 48, don't they? So the 2R plus 4R covers the whole 48. Do you see that equation? There's our equation. That's what they want in part A. They want the equation. So there's the answer to part A. And then in part B, you go ahead and solve that equation. So let's solve for R there. How do we solve?
You add the 2 hours.
And what's 2R and 4R?
6 hours.
6R is 48. Last step to get,
6 hours.
divide by 6 to get R alone. Divide by 6 on both sides. So R equals, was that 8? So R is 8. What is R again? I mean, no, I know it's 8, but like, what is it?
The speed of the slower.
Yeah, right up here, notice. R is the rate of the slower. Now, is that what they asked me for?
No, they want the highest one.
Right here. Speed of the faster. So this is the speed of the slower. So what's the speed of the faster? 16 miles an hour. Because it's double, right? Because they said 2 times as fast. Does that make sense? A little bit of physics there. So there it is. All right. So that will be on YouTube if I went too fast in any way. Let's see. Let's go to number 3. Here's another cyclist. 2 cyclists, 63 miles apart, start running towards each other at the same time. One cyclist 2 times as fast as the other. They meet 3 hours later. What is the speed of the faster cyclist? Can you do that one? Super.
I got 7 for the slowest route and 14 for the fastest.
Distance equals rate times time. So we have 2 boxes under each letter. We're going to do the same thing we do. We have the slower, faster. So the slower is R. The faster is at 2 times as fast. Okay, same thing. 2R. Okay. 63 miles per hour. That 63 is going to go down here, right? They meet in 3 hours. So it's 3 for both the times. So they both travel on their bikes for 3 hours. All right, so we get the 4 boxes from the words. And how do we get the front 2 boxes? From the equation. Distance equals rate times time. This will be 3 times R, 6R. And then there's our equation right there. 3R plus 6R is 63.
Yeah, over 9,
Good.
7.
So 9R is 63. Divide by the 9. And the R is 7.
And then you multiply by 2.
Yeah, because what did they ask for? They asked for the faster cyclist. Faster's right here, right?
Right.
So 2 times R is 14. So the answer they wanted 14. Watch out, you don't want to do all that good work and just forget that very last little step.
That's the part that I was missing. Okay.
Make sense? That good? Seeming easy enough? All right. Let's keep moving on. So number 4. After robbing a bank in Dodge City, a robber gallops off at 14 miles an hour. If you can read that there. 14 miles an hour. 20 minutes later, the marshal leaves to pursue the robber at 16 miles an hour. How long in hours does it take the marshal to catch up to the robber?
So this is the same thing.
It's another travel problem, but it's a little bit different. They're throwing a curveball at us this time, right?
They're using money. Oh, no, that's the next one. Sorry.
Yeah, next is money, yeah. All right, so this one's got a little more trickery to it. Room
This
here.
time is 20
And then
minutes.
the other one's going to be 6.
Distance is rate times time, the dirt equation.
And right now, we're trying to find distance. Because that's what we're missing. We have
Right.
time.
All right. So what are the 2 things? So we don't have a slower and faster cyclist on the left. What do we have?
A cop and a...
Yeah, we got the, who was the first guy? The robber?
Yeah.
The robber. Sounds funny. Okay, the robber and the marshal.
I didn't say more.
All right. And let's take the numbers one. You remember the game plan, right? Step 1, get how many boxes? 4 boxes from the words. All right, so let's get 4 boxes. First, here comes a 14 miles an hour. Where's that?
That's going to be rate.
Rate for who?
That's going to be rate for the robber.
Robber rate. 14 miles an hour.
And then 16 is the rate of the marshal.
16 marshal rate. Yeah.
And time will be 20 minutes later for both.
Yeah, now what does that mean? 20 minutes later.
That's just when he leaves.
Yeah. First off, we got to watch out. They're throwing several curveballs at us, right? And we're not like the Astros that know the pitch that's coming, right? Those cheaters. I'm a Dodger fan, so I'm a little irked. But anyway, so 20 minutes
1-0.
is mixing in with hours. Notice. And you can't do that. You can't mix time. You got to make them all the same time. Specifically, hours. See how they said hour? We want an answer in hours, please. So we got to take that 20 minutes and change it to hours before we do anything with it. We got to make sure everything's in hours. We can't be doing minutes and seconds and days. And it's all hours. So 20 minutes. How many hours is that?
1/5 of an hour.
1/3.
1/3 of an hour.
I mean.
Right? 20 makes 60, makes a whole hour. So 20 minutes is 1/3 of an hour, isn't it? Okay, so that's the first thing. We got to get over that curveball. They're trying to trick us with that changing up the time thing. So 1/3 of an hour. So 1/3 of an hour later, the marshal leaves. Think about what that means. So a little map is always helpful, I think, or a little diagram. So we got the robber who takes off, right? Here's the robber. And then down here's the marshal. And he leaves 1/3 of an hour later. But then he's faster, so eventually he catches up. Right? So if he leaves 1/3 of an hour, so when he catches up, when he eventually catches up, he will have traveled more time or less time than the robber? Less time because he left later.
Yeah.
By how much less? 1/3 of an hour. 1/3 of an hour. So in other words, the marshal's time is X minus 1/3, and this is X. Or T if you want. I just like using X. Do you see that? See, I don't know how long the robber went for. Call it X. But the marshal went for X minus 1/3. He went 1/3 less hours. That was his time, right? He will be galloping 1/3 less time than the robber, huh? Does that make sense? All right. So now we got 4 boxes. What are you doing? So step 1's over. What do you do in step 2?
Get the other
14
2 using the equation.
Yeah, other 2 by the D equals R times T. So I get the front to the D boxes, right? Remember, D equals R times T. So this is going to be 14 times X. And this is going to be 16 times X minus 1/3. Do you see that? We good there? That makes sense. Now, what's step 3 about? Some kind of equation. It's not always adding. Equation from the front boxes. I'm going to use the 14x and the 16x minus 1/3. And I'm going to write some kind of plus or minus or maybe just equals. There's got to be an equal sign somewhere. That's what an equation means, right? That's what I put back here for you. I said, the third box, the third step, front 2 boxes, some kind of equation. Notice I didn't say add or subtract. It can change. So what's it going to be? Equal sign? Just, you mean just put an equals right between them like that?
You have, I think it's subtraction, don't you have to find the difference?
So think logically about what's happening here. So what is this? The main thing is, if I was to give one tip, so if you're headed the road of STEM, let me help you down that road. That's where I went. One thing I really learned that really helped me over the years is be as real as you can with word problems. I've noticed I'm kind of half in, half out, half real, and just half X's. Here's what I mean by real. What is that 14x? I mean, real life. Is it how much the horse weighs? No, clearly not. I'm being silly. Is it how fast the horse went? Is it how far what is it?
It's how far the robber went.
It's a distance, right. It is how far. It's how far who? The robber went. Beautiful. And what is this? Distance the marshal went. Well, look at this diagram. You tell me about the distance the robber went and the distance the marshal went when you catch up. What does that mean? If one runner takes off and another is faster and catches up.
Yeah, just like Olympus.
At the moment of catch up, what do you know about their distances? Of course they're equal. That's what it means to catch up. You've traveled the same distance at that moment, huh? Does that make sense? Yes, so Sabino's right. We set these equal. Does that make sense? We don't add them or anything. That's what it means to catch up. It means same distance at that moment, huh? So yes, they have to be equal. Exactly. All right, so they are equal. So now there's our little equation to solve, which looks a little painful. All right, let's do it. So 14, because we got a fraction, I mean. And then distribute that 16 through there. So this one we didn't add or subtract. It wasn't like the other one, the other two, where we had people coming towards each other, and so we added up to cover the whole distance. That was a little different. These are not people coming toward each other, are they? These are people going in the same direction, catching up. So the idea of catch up means total distances are equal. Minus, and 16 times a third. Well, that 16 will go on the top, won't it? Because it's 16 over 1. We okay there? Right, because whole numbers are over 1, aren't they? That 16 is over 1, goes to the top. So far, so good? Yeah. Now, we got to get rid of that fraction. We don't want no fractions. So what do we do whenever we have an equation with fractions? We get it out of there with the least common denominator. What is the least common denominator? The only denominator is a 3, right? So here we go, 3 over 1, but here too, 3 over 1, 3 over 1, right? Everybody gets one, and then these cancel, huh? So what do we get? 3 times 14 is what? 42x. 3 times 16, 48x minus 16. Is that okay there? So I just multiplied through by 3. That's what you do when you have a fraction, a denominator. Just multiply through by LCD over 1, LCD over 1, LCD over 1. Get to here. Now we're trying to solve for x. What do you do when you have x's on opposite sides of the equal sign? Yeah. Subtract 48x from both. Oh, boom. Bring it over here. That'll make it... I'm running out of room here. It's a long problem. These problems go on and on and on. So you get minus 6x is minus 16. Is that good so far? Do you see what happened there? Last step. Divide by minus 6. X equals, I don't know. What? Just give 2. Oh, it's going to be an ugly one. Okay, the two negatives cancel, right? Two negatives make positive. And I'm just going to reduce it. Divide by 2 top and bottom, 8 thirds. I'm just going to leave it that way for a moment. Now, is that our answer?
No.
How do you know? Is that our final answer? So this is another one of the many tricks with word problems. Is X may or may not be your answer? Sometimes it is, sometimes it isn't. What you have to do is you have to go back and pay really close attention to the question. What was the question? How long in hours for what to happen? To catch up. Right, we could change it and everything, but hold on. Is X my answer? Well, you have to go back to the boxes. This is X right here, right? So what is X? I mean, this is where I'm saying be real. The main thing, be real, be real, be real. What is X? I mean, in real life, what is it? It's robber's time. Is that how long it takes to catch up? Is it the robber's time that'll tell us? Who catches up? The marshal, not the robber. So what we have to find is this box. So what we really want is X minus a third, not X. Everybody see that? This is not simple, is it? This is not for the casual. STEM is not for the casual. This is hard. I had to give my life to these kind of things. I mean, I did. I spent my life learning, for 8 years studying problems like this night and day, 60 hours a week probably. These don't come easy. But there's a lot to this. So x minus a third, so this is 8 thirds minus 1/3. That makes sense? Why did I turn to x minus a third? Because that's what catching up means. Catching up, who caught up? The marshal. So you got to find the box they want in the end. X minus a third, 8 thirds minus 1/3. 7 thirds. 7 thirds of an hour. Yeah, I don't know if they want a decimal or fraction. Probably they'll take it like that, I think. 7 thirds of an hour, which is 2 1/3 hours. That's how long it takes the marshal to catch up. Ooh. How about number 5? You are choosing between 2 different cell phone plans. The first plan charges a rate of 27 cents per minute. The second plan charges a monthly fee of $39.95 plus 12 cents a minute. Okay. Let T be the number of minutes you talk, and C1 and C2 be the cost in dollars of the first and second plans. Give an equation for each in terms of T, and then find the number of talk minutes that would produce the same cost for both plans. All right. It sounds fancier than it is. This one won't be nearly as hard as those last couple. It won't be bad. I bet you'll generally know what to do if I just gave a couple pointers. So let's do the first plan. So plan 1. So plan 1 says the first plan is 27 cents per minute, period. So it doesn't matter how many minutes you talk. It's just 27 cents for every minute. So, and how long do we talk for? Let T be the number of minutes you talk. So say now if you're looking at this and like, I'm confused, I don't know what to do. I bet you do. You know, another trick I learned with millions of word problems I solved through physics and chemistry and engineering and math classes is I learned to put in numbers. And that helped me think so much better. So if I read something crazy and I go, I don't know all those words, then I'd stop and go, okay, well, I don't know. What if I talked 10 minutes? Let me just we do better with real numbers. What if I talked for 10 minutes? And this plan is 27 cents a minute, right? That's plan 1. What would be my bill? I would take 27 times 10, wouldn't I? So what if I talked for 30 minutes? What would be my bill? So what if I talked for T minutes? 27 times T, of course, huh? That's just 27 times. See how much better you think with numbers? I do too. So if you're reading some crazy word problem with letters, just start sticking in a 10. See how I'm real? I'm just always coming back to being real. That is the key. Be real with it. Not that makes everything easy, but that's how you eventually learn it, is being real. Okay, plan number 2. Plan number 2 is a little more complex, not a lot. It's $39.95 like up front. That's just like, you got to hand us $39.95 plus 12 cents a minute. So let's be real again. Let's think, what if I talked 30 minutes? What would I pay for that plan? So again, it's $39.95 up front plus 12 cents a minute. I don't mean the final answer, but what would you do if you talked for 30 minutes? Every one of us could figure out the bill there with our calculator, right? What would you do? 12 times the 30 minutes plus the $39.95, huh? That's right. That's exactly right. So instead of 30 minutes, it's 12T, isn't it? Yeah. Oh, these are cents. So that should be 0.12, and the 27 should be 0.12. I forgot. Those are cents. Right? So put a decimal in front of those. Yeah, there's the 2 formulas. That's C1 and C2. Does that make sense? Yeah. On that? So they're going to go into a whole host of problems. We still have to do part 3, but before we do, I just want to give you news. They're going to go into a whole host of problems now where they have like a fixed part. The $39.95 is fixed. It's just straight. And then the 12 cents a minute, that's variable. It has a variable next to it. And it varies. The more you talk, the more it is. Whereas the $39.95 is set. Fixed and variable. Okay. So there's the 2 equations. So this is 0.27t, and this is 0.12t plus 39.95. Okay, now what do they want me to do in the final part?
You have to find out like what.
Yeah, if you talk for how many minutes, the two plans will have the same cost. So what do you do to figure out same cost? Same
You equate the
is equal. Exactly. Same means equal, right? Same cost means they're equal. So you take the 0.27t and you set it equal to the 0.12t plus 39.95, and you solve for t. You find out what time will make them equal. What's the value of t that'll make those two equations equal? So how do we solve for t? Yeah, same thing. When we got t on both sides, we got x on both sides, get rid of the lower one. So subtract 0.12t from both, like that. That leaves 0.15t, and this is 39.95. Last step to get t alone, divide by 0.15, and then pull out the handy-dandy calculator and let me know, please. You got a number there? I got a calculator too. I'll race you. Ready? What is it? 166? 266. Thank you, Sabina. 260. So 200. And so if you talk for 266 minutes, the two plans will be equal cost. So what if you go less than 266 minutes? Which plan would be cheaper for you? Plan 1 costs more per minute, but less up front. Huh? So if you go less time, then that's going to be a cheaper plan. Yeah, plan 1 will be cheaper. But if you go more time, then it's better to have the big up front and the less per minute. Huh? So 266 minutes is the break point. That's how businesses would calculate different things and what they should do. Right? And found out what makes them equal. We good there? All right, I'll move on. Let's see, number 6. A rectangular room is 3 times as long as it is wide, and its perimeter is 40 meters. Find the dimensions. 3 times as long as is wide, the perimeter is 40. Find the dimensions. Okay. So it's talking about a rectangle. So let's draw one. I think that'll help. So if we draw a rectangle, and this is width, length, what is the perimeter of that rectangle? Remember, perimeter means all the way around, doesn't it? Right? You know, let's say like the security guard walks the perimeter, like around the edge, right? So if you're starting here, and you go that way, that was W, and that way is L, and then that way is another W, and that way is another L. So what's the total perimeter you just covered? 2 widths and 2 lengths, isn't it? Add it up. Does that make sense? The perimeter of a rectangle is 2 widths plus 2 lengths. So there's the formula we always use. You can put that right on your 3x5 card for the next exam. 4x6 card for the next exam. Perimeter for a rectangle, 2 widths plus 2 lengths, and the dirt formula and all that other stuff. All right, so a rectangle, now it's 3 times as long as it is wide. What does that mean?
So that means
So you
we
got
have
3 times as long, so you go 3 times L, which is
Yeah.
3 times 2L.
Well, careful. I think L is 3W. The length is 3 times the width. Right? See how this sentence? Length is equals 3 times the width. That's what they're saying.
Yeah, that's what they're saying.
Right. Okay, so, and then they're telling me the perimeter is 40. So I can pop a 40 right in there for the perimeter. Let me bring that down here. 40 for the perimeter is 2W plus 2L. Good so far. I just popped a 40 in for perimeter because they told me perimeter is 40. And now I can't solve an equation with 2 letters.
Yeah.
I need to plug in for one of them, don't I?
Well,
Oh,
See what I'm going to do?
L is 3W.
Yeah, so that's what we're going to do. We're going to take this and put it right there in the place of L. That way it'll be all just W.
Okay.
See how that works? So I took the basic equation for perimeter of any rectangle. Perimeter is 2 widths plus 2 lengths. Put in the perimeter 40, and I knew the length was 3 widths, so plug that in for L. So then what are we going to get? 40 is 2 widths plus 2. And what is L? 3W. L is 3W. In fact, let me change the color for extra clarity there. 3W. Okay. Let's solve that thing. So that means 40 equals 2W plus 6W, right? 2 times 3. And that means 8W. Last step to get W alone. Divide by the 8. W is 5. So the width is 5. Do they want the width? Yeah, they do here. 5. How do we get the length?
Multiply by 3.
Yeah, remember we had length is 3 times the width? So the length, 3W, 3 times 5, the length must be 15. And there we go. You can double check to make sure. Let's check. So they're saying that it's 15, 15, 5, and 5. Does that add up to 40?
30 plus 10. Yep.
Yeah. Perfect. And it's 3 times, huh?
Yeah.
See how it's all working? All right. Number 7. The area of a triangle can be found using areas of half base on side. Remember the area of a triangle formula? Have you seen that before?
Yeah.
Find the area of a triangle, picture below, where the measurements are given in meters. Okay. So it wants to find the area of that triangle. That won't be too bad. Area is a half. Base times height. So area is a half. What's the base? Is that 11, huh? And what's the height? Is that 2? That's the height. That's the base. So it's just, there's no X's or anything. It's just hit the buttons on your calculator.
You guys still like rise over and run.
Yeah, right. So it's just 11. That was a nice break there. Just plug in the numbers. No X's. No fancy stuff. No W's or L's. All right. Good there. Multi-letter equations. So this can be a little tricky. Okay. So let's see. What do we got here? R. Move it up here. R. Let's bring this up here. Times NF plus Y equals B plus T. Okay. Solve the equation for the requested variable. So in this first part, they want us to solve for R. R. Here's R right here. So what's tricky about these? These can be kind of challenging. These are multi-letter. So you have to kind of keep your eye on the ball, so to speak. What I used to always say to my kids forever at tennis, keep your eye on the ball. So, or keep your eye on because they're going to change the ball, and then they're going to say, now go for F. So right now we're focused on R. Keep your eye right there on the R. So you're wanting to get that R alone. So if we want to get that R alone, here's the equation. So R is over here saying, I want to be alone. Get rid of all this stuff so that I can be alone. What would we need to do to get rid of all that stuff? You can just divide by the whole thing, huh? Right? Gonzo, gonzo. Whatever you do to one side, you have no choice but to do the same thing to the other. Everybody see what happened there? E plus T over NF plus Y. R's alone. So that's the answer for the first part. Now they want us to redo it. And this time, so we have R, so start again. NF plus Y equals B plus C And this time, who are we solving for? F. Now, F's right here. Again, keep your eye on the ball. I'd encourage you to circle it. Just kind of focus your attention. We're trying to get that piece alone.
Hey, pull it out.
So in this case, we better get rid of those parentheses. We better distribute through the parentheses. We didn't have to do that in the last one. We could just divide and be done. But this one, we're going to need to do so. So let that R go boom and boom. And we'll get R in F plus RY is B plus T. Is that good so far? Everybody see what happened there? And keep focused on the ball, so to speak. There's the F. The F wants to be alone, right? In the end, we want F alone. So what should I do next to move towards getting F alone?
Take the R and Y over.
Yeah, subtract the R and the Y. Yeah, subtract the R and the Y from both sides. Just like that, and gonzo. That makes sense there. And it's R in F equals B plus T minus RY. And F is still right here saying I want to be alone. Yeah, because those are just both multiplied, huh? So we just divide by Rn, divide both sides by Rn. And that's it. That's our answer. Well, can we cancel some of that stuff?
Yeah, nobody, no.
Can we cancel this R with that R? Why not? Costco says no. Right. Pluses and minuses glue things together. Right? Pluses and minuses make them a package deal, which means you buy all or you buy nothing. Right? If these were times, if that was B times T times R, RY, then you could totally cancel the R's. It wouldn't be the Costco glue stuff. But yeah, pluses and minuses are like glue. They're packaged together. We can't touch them. So that's the answer right there to the second part. Is that good? Should we try the next one? X plus 7. Add in. So what they're saying, if you have more than one item in the top or the bottom of the fraction, you got to put parentheses around it. I think we talked about that once, but it couldn't hurt to mention it again. So yeah, when you type this in, for example, you're going to have to go parenthesis B plus T, because we have more than one thing in the top, a whole bunch of things, huh? Minus RY, parenthesis, divided by, and we also have two things in the bottom. So parenthesis R in parenthesis.
Oh, okay.
Does that make sense?
Okay.
So if you have more than one thing in the top or the bottom, you're going to have to put parentheses, because that makes the whole group hang together in the numerator or denominator. That's what parentheses really are, is a grouping symbol, saying this group hangs together. And so for this one right here, we would have had to have typed in parenthesis B plus T parenthesis
Basically,
divided
it's a
by.
lesson that we're learning, and it's not on the test. Okay.
Right, yeah, it won't be something you need to worry about in the test. That's true.
Oh, that's what I
And
have.
there we go. But for the homework, that's how you have to enter it. Yeah, parentheses around the numerator and denominator because there's more than one thing. Yeah, good. All right, let's go on to number 9. I'll put it back here where we got a little more room. So number 9 is x over 7 plus y over 5 equals 1. All right. So, and what do they want me to solve for here? Y. They want solve for y. They could have picked x or y. They picked y. So solve for y. Can you do that one? Multiply through by it, right? So I hope your first step is
LCD,
LCD. And what is the LCD?
35.
35. Beautiful. And what do you do with the LCD?
Crisscross, have fun, 35 over 1.
Beautiful. 35 over 1. 35 over 1. And the right side. Don't forget the right side. Got to do both sides, right? Right? The LCD, 5 times 7, 35. And multiply by LCD over 1. All right, take it for the next step. 7 into 35 5 times, so we get 5x. 5 into 35 7 times, so we get 7y. And on the other side, it's just 35. Huh. So we good to hear?
Yeah.
No more fractions, which is always nice. And what are we trying now? Got to keep your eye on the ball. Who's the ball? Who we want to get alone? The ball is y. So in the end, we want y. So what's our next step to move towards getting y alone? Subtract that 5x. Cancels here. Can I subtract 35 and take away 5 to get 30? No, they're unlike terms, huh? If that 35 had an x, then I could, huh? That'd be 35x minus 5x. But it doesn't, so I can't.
I always looked at it as the Costco deal.
Well, Costco's for dividing.
Oh, yeah, you're right.
For dividing. And what's our last step to get y alone? Divide by the 7. There we go. And yeah, here is the Costco deal, huh? We can't go 7 into 35 because it's part of the blue package. So that's just it right there. There is the answer. So make sure when you type it into the canvas, you go like that. And you don't need parentheses on the 7 because there's only one thing in the denominator. So no parentheses needed there. But whenever you have more than one thing, you got to put parentheses around it for the numerator. Easy one. They want you to solve for P. They just say P equals and have a blank. Can you solve that equation for P? Yeah, so that one will be easy for you. Just subtract the I from both sides. Gonzo. P equals S minus I. That good? S minus I. There we go. All right, that was a nice easy one. Now 11. Going to bring in some pi's here. So S equals 2 pi r squared plus 2 pi r h. And they want you to solve for h. H on this one. So there's the h. Here's the wall. H is saying, I want to be alone. Get rid of all that stuff. Yeah, but we're not going to put in the number. Pi, you're right, it's 3.14 and it goes on and on and on. But just use pi, and the way they have you type it in the answer is you just type pi and it'll make a pi. Yeah, that's what they say. I was just reading the thing. It says it right on the problem. You'll see it. Yeah, so pi is just a Greek letter. It simply is a Greek P in the Greek alphabet. You know, alpha, beta, gamma. I don't know if you heard of the Greek alphabet. It's just the P. So it's just a letter. It's just a Greek letter.
You're trying to...
You're about to put the answer, you put the previous.
2 pi r squared. 2 pi r squared from both sides. S minus 2 pi r squared. 2 pi r h. Good to there for that first step. Yeah, right, yeah, so yeah, last step. H wants to be alone. Divide by that 2 pi r, exactly, because that's all just multiplied, huh? So divide by 2 pi r. What do you do to one side? You have no choice. Do the same thing to the other. And there we go. That's really the answer. So to type it in, you would need to go, parentheses, huh? Because there's more than one thing in the top. S minus 2. And you type pi. Literally just type the letters pi, and it'll make that pi for you. R. And then how do they do the squared? Up arrow, let up arrow, 2. And then divided by, and then you got to put parentheses because there's more than one thing in the bottom. 2 pi r parentheses, like that. Not making sense? And you type that in. Questions on number 12 is a word problem. It says one angle in a triangle has a measure that is 3 times as large as the smallest angle. The measure of the third angle is 15 degrees more than that of the smallest. Find the measure of the largest angle. Okay, so a little bit of word problem, small, medium, and large angles. So we have the smallest, the medium, and the large. I'll just set this up. That'll help us. Just get a little formula for each one. And what does it say first off? One angle has a measure that is 3 times as large as the smallest angle. So one of the angles, well, I don't know. I don't know which one's small, medium, and large. Let's just say small, other, and other, because I really don't know which one's medium or large yet. All they mention is the smallest, and then in the end they want me to find the largest, but they don't say which is which. So I'm just going to call it small and the smallest, and then the 2 others.
So we're in a triangle.
Yeah, triangle. Yeah, so we're in a triangle. This is a triangle. Yeah. Do you remember the key fact about angles in a triangle?
They all add.
Yeah.
They add to 180. Yeah, it's about the only geometry fact you might. Well, that's not 100% true, but yeah, you do need to know that fact. In a triangle, angles, the 3 angles total 180 degrees. In a triangle, the 3 angles always total 180 degrees. Okay, let's get back to the main part, is the words here. One angle is 3 times as large as the smallest.
So we could do that.
Yeah, so if x is the smallest, then one of the other ones is 3x. Exactly, that makes sense.
X plus 15.
And the other one, the third angle, is 15 degrees more than the smallest. X plus 15, yeah. Is that making sense? So the smallest is x. One of the other ones is 3 times that. And then the other one is 15 more than that.
It wouldn't be 3x plus 15?
No, it's just 15 more
Oh, yeah, I see.
than
More
the smallest. Yeah,
Which is-
exactly. Okay, now what am I going to, okay, I got that. What am I going to do with this formula, and that formula?
You add them all together.
Yeah. Yeah, add those 3 up and make them equal to 180. Exactly. So x alone plus 3x plus x plus 15, right? Those are the 3 formulas. Have to add up to be 180, don't they? Because the 3 angles in a triangle always total 180 degrees.
And they don't need to be separated.
So now we'll gather like terms and solve just like normal. Yeah, just normal solving now. So yeah, what's x, 3x, and another x? 5x, yeah, because it's 1, 3 more, and another 1, so that's 5x plus 15 is 180. That good? Just normal equation solving. Subtract the 15 from both of them. Like that. So what do we get? 5x was that 165. Last step to solve for x.
Divide by 5 and you get 50.
Divided by 5. So x is, what is it? 33. Thank you.
That's the smallest.
So yeah, so now we got to go. They asked for the largest. Notice the largest. So we got to take our answers now. Now that we know what x is, we can go up and find the small and the other 2. So the first one, the smallest one is x, so that's just 33. The next one is 3 times x, so that's 3 times 33, 99. The third one is x, which again, x is 33. Add 15, it's at 48. So what's the largest? 99.
I got x plus 15. I was like, how'd you get 99?
Yeah, so I just took that 33. Once you had x, the mystery's over. You can plug in. So I plugged into this formula, x. I plugged into the 3x formula and the x plus 15 formula. I just kept plugging in 33 in the x slot because I learned that x is 33. And I got the 3 answers, 33, 99, and 48. So who's the largest side, largest angle? 99. 99. Good. Okay, statins. Number 13. Statins are used to keep cholesterol in check and are a top-selling drug in the U.S. The equation S minus 1.3x equals 5.6 gives the amount of sales S of statin in billions of dollars, X years after 1998. According to this equation, how much did people in the U.S. spend on statins in the year 2009? So that will, how much did they spend?
Can you be 8 minus 2009?
You gotta be real with this.
That's right. We gotta be real. It's all about being real.
That would be 2009 minus 1998.
Exactly, yeah. Did you catch the main, well, there's a lot of important things here, but one of the most important things is x. This is something they do quite commonly in science problems. X is years after 1998. So, in other words, suppose this is the year 2000. What is x? How many years after 98 would that be? That'd be 2. X would be 2, right? And the year, but they're giving us the year. What year?
2009.
2009. So in the year 2009, subtract 1998, and we get x equals what, 11? That's 11 years after 1998, isn't it? That makes sense? So they're basically telling us x is 11. If it's the year 2009 and x is how many years after 98? X is 11. So just take that 11 and pop it in for x into that equation. So just grab that 11, plug it in right there. So we'll get s minus 1.3 times x, x is 11, equals 5.6. Hit the buttons on your calculator. What's 1.3 times 11? I'm getting 14.3 equals 5.6. And so how do we finish solving for s? Add the 14.3. So s equals 19.9. That's billions of dollars.
Wow.
It's a lot of money. There it is. 14. A wire 19 centimeters long is cut into two pieces. The longer piece is 3 centimeters longer than the shorter piece. Find the length of the shorter piece. All right. So just lots of word problems. So if you have a piece of wire and you cut it, let's say here, we're going to cut it right there. Then the longer piece is 3 centimeters longer than the shorter piece. So call this x, this is the shorter. And this is going to be the longer here. Oops, I'm writing over the top of it. This is going to be the not the logger, but the longer. The longer piece from there to there, the shorter piece from there to there. The longer piece is how much longer?
3.
So x plus 3, huh? Does that make sense? 3 longer. All right, and now the wire is 19, isn't it?
Yeah.
So we're going to take the x plus 3, the x, they must add up to be 19. So can you solve that equation for x? And so x plus x? Yeah, because it's invisible ones that are 2x. Plus 3 is 19. X is going to want to be alone. Subtract 3. 2x is 16. Last step. Divide by 2. X is 8. Now, careful. They're asking for the shorter piece. Is that x?
No.
So it's 11.
The shorter piece is x. So it's 8. It is 8.
Oh.
In this case, it is, huh?
Yeah.
Right? The shorter is just x. If they'd asked for the longer, that'd be the 11. But they asked for the shorter on that. You good there? 15. The sum of 3 consecutive numbers is 972. Find the numbers. 3 consecutive numbers. Okay. Let me move that one over to where we can see it. And have some room. Okay. So 15. 3 consecutive numbers. Sum, right? The sum of 3 consecutive numbers is 972. Is 972. Okay. What are consecutive numbers?
So like 1, 2, 3.
Yeah, numbers in a row, like 17, 18, and 19, or
Yeah.
26, 27, 28, right? In a row. Okay, so numbers in a row. Well, how do you represent numbers in a row? What you do is you always let the first one be X, the next one, if the first one's 17, the next one is one higher,
Yeah, X plus 1.
X plus 1. And the third one,
Plus 2.
X plus 2, exactly. So any kind of word problem in which they speak of consecutive numbers, you just let them be X, X plus 1, X plus 2. And then it says their sum.
So you add
Yeah. Can you add them up and finish it from there? All right, so I'm going to jump in. X, X plus 1, X plus 2, add up to be 972. So that means 1x, a second x, a third x, so 3x, and then 1 plus 2, 3x plus 3 is 972. X wants to be alone, subtract 3 from both. 3x is, what is it, 969? And then last step, divide by 3. So what is x there? 323? 323? So x is 323. And what are they asking for in this problem? They're asking for the three numbers.
So 324, 325.
Yeah, so that's x, which is your first number. So the numbers are 323 and then 324 and 325. Those must be the three numbers. Not too bad? See, the bank robber ones were the hardest, those travel ones, huh? All right, so we have a couple. We got to go to number 18, and then we got a whole other section, but it's an easier section, though. All right, 5 subtracted from 7 times the numbers. Okay. 5 subtracted from 7 times a number. 5 subtracted from 7 times a number is minus 173. What is the number? Can you try that one? How are we doing here? 5 subtracted. That means the 5's in the back, huh? 5 subtracted from 7 times a number, 7x, is minus 173. All right, and then we solve for x. X is going to want to be alone. Add the 5. So 7x is, I don't know, what is that? Thank you. Negative 168. And then divide by the 7. I'm hoping that goes in nicely.
It does.
You get negative
84?
24.
24. Well, I'm way too high. 24, not even close. I'm in the ballpark there. All right, negative 24, and that's all they want. Well, actually, they want the equation as the first answer, and then they want the answer on that question. We good there?
So they want the.
Yeah, they want this equation. They first ask you for the equation, and then they ask you for the answer.
So they want the equation, which is 7x minus 5.
Right, what I circled?
Oh, okay.
Yeah. And then they want the answer, yeah. All right, 17 and 18, last two. Then we'll jump into the other section, which is much easier than this one. I would suggest on 17, 18, you don't use any x's. I mean, why use x's if you need? Those other ones we had to. You'll see what I mean. You'll sense it, and you'll, I'm sure, feel the same way. So read number 17. Summer needs to rent a car while on vacation. The rental company charges $19.95 plus 17 cents for each mile driven. If Summer only has $50 to spend on the car rental, what is the maximum number of miles she can drive? I mean, you could do an X. I could show you how to do it with an X, but I think you'd have an easier time of it by just taking out your calculator and just whipping out the numbers. I bet you could figure it out without using any X's at all quicker than you could with an X. So what are we going to do? She has $50 to spend. The rental car is $19.95 plus 17 cents a mile. how far can she go? So what would you do? So she has the $50, and the car is $19.95 up front. Yeah, so just subtract the $19.95 right away, huh? Which is basically $20 with 5 cents left over. So she has $30.05 left after she pays the upfront. Yeah, and then just divide that by 17 cents, right? She has $30.05 left after she pays the upfront charge, and then just divide that by the 0.17, 17 cents a mile. And what do you guys get? I have no idea what the answer is. Exactly, or?
0.76.
0.76.
Oh, 176, okay, so 176.76, and it goes on and on. So what does that mean is the answer?
One way or two.
Do we round it? Is it 177? Good, 176, huh? Because she can go 176 and a little bit more, almost another mile, but not quite, so she can't really go 177 miles. That would be more money than she has. She can go 176 miles. That was easy, right? Just use your calculator. I'm sure they do it with a big old fancy X, and you could, but why bother? Same thing on 18. An executive engineering firm earns a monthly salary plus a Christmas bonus of $7,600. If she earns a total of $85,600 per year, what is her monthly salary in dollars? Again, we don't need a calculator. She made $85,600 per year in a year, and the bonus, the Christmas bonus, was $7,600. So subtract the 7,600 to see what, because the rest is her monthly salary, which we're trying to find, huh? So take out the bonus, and you'll find out what she's getting paid regularly. Right? Take out the bonus. That was like a special thing. And you'll have left like her regular salary. So isn't that like 78,000? Exactly. Then just take the 78,000, which is her regular salary without the bonus. Divide by 12 months in a year. That's helpful to know. What is the answer there? 7? No, 6? 6,500. Yeah, there's nothing there. 6,500. So I would just do those two that way. I wouldn't bring in an X on those.